I'm Edson Camacho, a software engineer, and in this podcast we will delve into a fascinating and complex topic: how to do reverse engineering software. A step-by-step guide for beginners and experts. Whether you are new to the world of reverse engineering or a seasoned professional looking to sharpen your skills, this podcast is for you. We'll explore techniques, tools, and best practices for dissecting and understanding software. What is reverse engineering? To start, let's define what reverse engineering is. In simple terms, reverse engineering is the process of deconstructing a software application to understand its components and functionality. This can be done for various reasons, such as debugging, software migration, or even enhancing security. Reverse engineering is like being a software detective solving the mystery of how an application works from the inside out. Why reverse engineer? But why would anyone want to reverse engineer software? There are several compelling reasons. Learning and education, to understand how advanced software solutions are built. Security analysis, to identify vulnerabilities and ensure that software is secure. Software maintenance, to update or improve software without the original source code. Competitor analysis, to analyze the features of competitor products. Tools of the trade. For effective reverse engineering, you'll need the right tools. Here are a few essentials: disassemblers and debuggers. Tools like IDA Pro and Ghidra. Decompilers, such as JEB and JADX for translating machine code back into readable code. Hex editors like HXD to manipulate binary files at the hexadecimal level. Network analyzers. Tools like Wireshark to capture and analyze network traffic. Step-by-step guide. Let's dive into the steps of reverse engineering. Preparation. Ensure you have the necessary tools and a good understanding of the software's environment. Static analysis. Begin by examining the software without executing it. Use tools to analyze the code structure. Dynamic analysis. Run the software and observe its behavior in a controlled environment. Reconstruction. Attempt to rebuild the software's functionality from your findings. Document your process thoroughly. Best practices. Here are some best practices to keep in mind. Legal considerations. Always ensure that you have the right to reverse engineer the software. Respect intellectual property laws. Documentation. Keep detailed records of your process and findings. Ethical conduct. Use your reverse engineering skills responsibly and ethically. Conclusion. That wraps up our step-by-step guide to reverse engineering software. Whether you're looking to sharpen your skills or tackle your first reverse engineering project, I hope you found this guide helpful. Remember, reverse engineering is both an art and a science requiring patience, precision, and a deep curiosity. Thank you for tuning in. This is Edson Camacho signing off. Until next time, keep questioning, keep exploring, and happy coding.